In this lesson, we're talking about our exponential function still, but now understanding the inverse of an exponential function, which is a log or logarithm. So again, right, thinking of the inverses, how subtraction undoes addition, division undoes multiplication, a log can undo an exponent. So here we're introducing the inverse of that exponential function. So notice how the base of the exponent of the exponential function will be the base of the log. Then here the exponent will always be what the log will be equal to. So then here, that what the exponential is equal to is part of that log. And the exponential function, the inverse, would be log base b of a is equal to x. So that's how you're going to read that. And so again, just that reminder here that we're going to read this as the log base b of a is x. So that is the inverse of our exponential functions here. So again, keep all that in mind. So like, for example, when we are writing, notice how I've got 3 to the 5th is equal to 243. So here's our exponential. Notice how the base is 3, so the base is going to be 3. Then notice here how our equation, or the exponent, sorry about that, the exponent was always going to be what our log is equal to. So this log is equal to 5. So remember, that is your exponent. That means here, the final, what we're going to have is to write this exponential as a log form would be log base 3 of 243 is equal to 5. So go ahead and just pause the video and try this. You try real quickly on your own. And here you go. You should have said that the base is 5, so log base 5. The exponent is 3, so the equation should be equal to 3. So the log base 5 of 125 is equal to 3. So now in example 2, do you think it's going to change with a fraction exponent? No. Notice how here we have our base. So log base 25 is going to be equal to our exponent, which is 1/2. So log base 25 of 5 is equal to 1/2. So go ahead and pause the video and try real quick here on your own. And here you go. Again, the base is 27, so log base 27. Here you have your exponent, which was 1/3. So log base 27 of 3 is equal to 1/3. And then again, notice how we could have a negative exponent. So is that going to change? No. So here again, you have that base of 4. So log base 4 is equal to the exponent, -2. So log base 4 of 1/16 is equal to -2. Go ahead and pause the video and try you try here. So here you've got base of 6, so log base 6 is equal to the exponent here, -1. So log base 6 of 1/6 is equal to -1. Then here you just have to remember whenever we get to in those exponents, right? That whenever you had that power of 0, it will always equal 1, and you can still write this again even as a log. So here I've got log base x, because that is our base here, of 1 is equal to your exponent, which is 0. So go ahead and pause the video and try this. You try here on your own. Here you've got log base 6. So log base 6 of 1 is equal to your exponent of 0. Then you can do the same thing when we have variables. So again, log base, well, the base is a. So log base a of c is equal to the exponent, which is b. So again, pause the video here or try this. You try on your own. And here you've got base of r, so log base r of t is equal to the exponent, which was s. So now we're going to go the other direction. What if you're given the log form and now we're going to write it? How is this going to look as our exponential function? Same thing, right? Remember that the base, so log base 9, is your base. Then remember the log was always equal to the exponent. So this is 9 to the first power, which is equal to 9, which also makes sense. 9 to the first power is equal to 9. So go ahead and pause the video and try this. You try on your own. You try 6. And here we go. So here you've got log base 5. So base of 5 to the 0 power, right? Because remember, the log is always equal to the exponent. So 5 to the 0 is equal to 1, which again makes sense, right? Because remember, any base raised to the 0 power is always equal to 1. So notice how everything matches. So then here, example 7. We've got a base of 2, so 2 to the 9th power. Because remember again, the log is always equal to the exponent, which is equal to 512. And then if you put that in the calculator, 2 to the 9th power, you will get 512. So here, pause the video, try the try. Here you've got a base of 6, so 6 to the 2nd power is equal to 36, which is also true. Then example 8. Even if you have the fraction, right, we can still have fraction exponents. So we have a base of 49. So 49 to the 1/2 power, because that is your exponent, is equal to 7. So go ahead and pause the video, try it on your own. And here you've got base of 64. So 64 to the 1/3 power, which is equal to 4, which again makes sense, right? Because this is 1/3 power, which is the same as saying the cubed root of 64. And the cubed root of 64 is 4. So now our last few examples here. Notice how, again, you could even have those negative values, right? And fractions. So it's all the same when writing the exponential form here. You have that base of 5, so 5 to the -3 power, which is equal to 1 over 125. Go ahead and pause the video, try the try on your own. Here you've got a base of 2, so 2 to the -5, which is equal to 1 over 32, which again also matches because 2 to the -5, remember, right, negative exponents, which meant we would write this as the form of 1 over 2 to the 5th, right? Reciprocate the base. And 2 to the 5th power is 32, or in this case, 1 over 32. So then here, we've got a base of 1/2. So 1/2 to the -3 power, which is now equal to 8. Go ahead and pause the video and try this. You try here. Base of 1/3. So 1/3 to the -2 power is equal to 9. And then last again, we could have our variables here. So notice how you have a base of f. So f to the b power is equal to b. Go ahead and pause the video and try this on your own. And here we've got a base of m, so m to the nth power, which is equal to b.